Hello, everyone. So let's discuss a Leetcode problem for today. And this is one of the problems within the blind 75 list. Today, we are going to discuss problem 435, non-overlapping intervals. The problem definition says, given an array of intervals where every interval is defined by start value and an end value, we have to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. That means you are given multiple intervals. Some of those intervals might be overlapping, right? So we have to remove, say like if they're overlapping, we have to remove some intervals, obviously, to make all the remaining intervals to be non-overlapping. And we have to calculate what is the minimum number of intervals that we need to remove. Okay, so let's look at the two examples here. For the first example, you see we have these intervals, 1, 2. Let's draw a timeline or real number line. So this is 1, 2, 3, and 4. Okay, so this is the one, and then we have intervals 1, 2, 2, 3. So 1, 2 is this, 2, 3 is this, right? And then we have 3, 4, 3, 4, and 1, 3. So 1, 3. Okay, now we see we have these intervals, and obviously we see here that these intervals are overlapping, right? So this one, A, overlaps with B and C, right? Okay, here, before you start solving your problem, you should ask your interviewer whether these values, like if the end value of one interval is the beginning value or the start value of another interval, are they overlapping or non-overlapping, right? So in this case, in this problem, they are not overlapping if the end value of one interval is the beginning value of the other interval. Anyways, here we see A actually is overlapping with B, right? Is overlapping. And A is also overlapping with C, right? Now, there are two ways to make the intervals, all the intervals, non-overlapping. One way is like if we remove, say, B and C, right? Sorry, if we remove A, so this is A and this is B and sorry, I just made a mistake again. So I call this B and this is C. So one way is just removing B and C, right? Or the other way is like if I remove B and C, you see what happens, right? So it's gone. Now the rest two intervals, A and D, remain like non-overlapping, right? But instead, if we just keep these two and remove A, even in that case, these three become non-overlapping. And in the first case, we removed B and C. So B and C are removed. So two of the intervals are removed. Or in the second case, we just removed A. So one of the intervals are removed. So there are two ways to make all these intervals non-overlapping, right? And the problem here asks for this solution. That means we have to find the minimum number of intervals that are non-overlapping. Okay, so let's look at another example. The second example here. So in the second example, you see we have like 1, 2, 1, 2, and 1, 2, right? So we have 1, 2, 1, 2, and 1, 2. We have three intervals. Now all of them actually overlap with each other. You see that, right? And this is obvious that we have to remove at least two of them, right? We have to remove at least two of them to make all the intervals non-overlapping, right? That is a straightforward solution. And for the third problem, we see we have, say, 1, 2, and then we have 2, 3. And now you see that these intervals are not overlapping. So in this case, the result is going to be 0. We don't need to remove any interval. Okay. So how do we solve this problem? Obviously, the first thing that, okay, another thing is we have to ask the constraints, like, is it possible that our input is empty? Here, for this particular problem, it says there are at least like 2 intervals, so it's not empty. But obviously, in your interview, the interview may say yes, the interval length might be empty. Okay. And the other thing is like, so let's try to build some intuition. So from the intuition, we know that the first intuition is we have to find the overlapping intervals, right? Okay, so let's go to a problem. So you see you have 5 intervals here. And so as we said, like the first intuition is that we have to find the overlapping intervals, right? One, okay, starts from 0. So 0, 1, 2, 3, 4, 5, 6. Okay, so this is the number line. Okay, so first we have to find the overlapping intervals. And as you know, one of the common techniques is to sort the intervals, right? Sort the intervals, and that way actually we can find the overlapping intervals very easily. Otherwise, like, it becomes overlapping. Checking overlapping becomes like order of n square affair, because we select one interval and then we have to check it against all other intervals, right? So we have to check it against the other n-1 intervals, and we have to keep on doing this for every interval. So that becomes order of n square if we don't sort. But if we sort it, actually it becomes easier. In that case, we can just check against our neighbors, right? So say 0, 1, and then 1, 3, and we can actually sort it, say, based on the start value. And you can see, like, once we sort it, it becomes like the sorting takes, like, for n intervals, the sorting would be n log n, and then we can just read it linearly and find the overlapping ones. So here, for example, say after the sorting, I will write them from A to A, B, C, D, E, and F. I'll write them like that. So let's sort based on the starting value. So sort based on the starting value. And if we do that, we see the intervals are going to be 0, 2. This is one of the intervals, right? Well, we call it A. And then there is 1, 3. Okay, we call it B. And then there is 2, 4. Let's call it C. And then there is 3, 5. Actually, the input here is like already sorted based on the start value, but we never know. Like, if it's not told in the problem, then we have to consider that this is not sorted. So you can always ask if the intervals, like input intervals, are sorted or not. If they're sorted, what is the criteria of sorting? Like, is it based on the start value or in the end value? Anyways, this was sorted. So even if I sort it based on the start value, now this is going to look like this. Okay. Okay, so 0, 2, 1, 3, 2, 4, 3, 5, 4, 6. Okay. Now, what we can do is we can actually start from the second one, right? We can start from the second one, and this is a very important thing. So this is the first intuition is like we sort it, right? If we sort it, it's easy to find the overlapping ones. And in interval problems, this is a common technique. We do sorting. So what we can do is we can start from the second one. So after the sorting, and then we can check if the starting value of this interval. Okay, so let's say okay, let's say this is the end. So to check the overlapping, obviously I'm going to check from the second interval, right? So initially the end is pointing to the end value of the first interval after sorting. And then what we are going to check is if this value, this one, is less than this, this end value. And if that is the case, right, because it's already sorted based on the starting value, so we start from the second one, and we check. So initially we set the end to the end value of the first interval, and then we start checking from the second interval to check for the overlaps. So if the starting value of the second interval is smaller than the current end value, in that case we can say that this one and this one is overlapping, right? So these two are overlapping, obviously. You can see here. Now we have to decide which one we want to get rid of, because if there are two overlapping intervals, we have to get rid of one of them. Now here comes the second intuition. So this was our first intuition, like how we can use it. And then second intuition is like once we find okay, using the first intuition, we sort it and it makes easier for us to find the overlapping ones. I can just when I'm checking B, I can just check against A, because that's the one that it may overlap. When I'm checking C, I will check against B, right? Because that's the potential one it can overlap. When I'm doing D, I will check against C. Okay, that goes there. And then we found that A and B are overlapping. So we need to get rid of either A or we need to get rid of B. So which one we want to get rid of? So here comes our intuition here. So you can think like you say, if I obviously I want to get rid of the one that ends later. Why is that? Because the one that ends later potentially has more chance to interfere or overlap with other intervals, right? So say if I just get rid of this one, right? If I get rid of this one, instead of that, because I want to minimize the number of intervals that I want to remove, right? So even if I remove this one, there is a chance that because B ends even later, so there is a chance that B is going to overlap with other intervals. So I want to get rid of the intervals that have late end values. In that case, I'm kind of reducing the chance that that interval is going to interfere or overlap with other intervals. So this is obviously, it sounds a greedy kind of approach, right? I am just making some assumption that the interval that ends late has more potential to be overlapping with other intervals, right? So this is a like greedy approach. Obviously, this is a greedy approach, and actually it works. So what we can do is we can just get rid of B, right? And now you see that once we got rid of B, what happened is the end actually still is here. Okay, the end is still here. Now let's get rid of, say, now I'm checking C, right? Now C, starting point of C, we check this again as a current end value. So B is gone. And what I do is I add 1 to the result. That 1 is gone. Now C is not overlapping with this end. You see that? So it's not overlapping. It's not overlapping. So that means we're fine. We don't have to get rid of anything. The only thing is we change the end value to this. Okay, because the next interval I will be checking is interested about this one. So I will be checking D, starting value of D with this, and this is overlapping. But as we can see, the end value, sorry, the last value of D is actually later than the last value of C, second value of C, so we get rid of D. Again, in a greedy approach. So another one. And finally, we check E again as this end, and these two are not overlapping, so we are done. Okay, so that means in total, we have to get rid of two, one here and one here, right? So this is the two of the things. And let's try this problem on the example 1 here. So the intervals here were 1, 2, 3, and 4. So after sorting them, let's say, since we are sorting them based on the starting value, say this one became the first one. This is A. And then 1, 2 became the second one. We call it B. And then 3, 4 became the third one. We call it C. Okay, sorry, I made a mistake here. Not 3, 4. 2, 3 becomes the third one, right? Because we are sorting based on the starting value. This is C, and 3, 4 becomes D, right? Okay, so we said like initially we will start checking the overlaps from the second interval. So initially the end is going to be set to the end of value of the first interval. And then I'm checking if this one is actually less than this, right? So we start from the second interval. And we see that the start value of the second interval is less than the current end value. That means this is overlapping. So we have to get rid of one of them. Which one we want to get rid of? The one that has a bigger end value, right? So you see this one has the bigger one, right? So we get rid of this one this time. And we set the end value to this, right? Okay, next time I check C, this one against this start value and value doesn't overlap, so they're not overlapping. Okay, anyways, we removed one here and they're not overlapping, so what we can do is we can just change the end value to this. Okay, and then next we check this D, interval D with C, and they're not overlapping, so we don't do anything, and that's it. So it's 1. Okay, so let's try to code this. Okay, so the first thing that we are going to do is check the edge cases. And as you see here, already it is said that interval, there are at least 2 intervals, but if that wasn't the case, I would have done this. If say intervals equals to null, or intervals length, sorry, if this was an empty one, if this is 0, then there is nothing to return, nothing to remove, right? So we return 0. Otherwise, what we do is we declare a variable for the result. We initialize it with 0. This one will count how many intervals we want to remove. And then what we do is we do a sort of the intervals, right? Arrays dot sort, that is the function. Let's stop this. Okay. And when you're actually practicing, you can just turn this on and off. Turning this on sometimes actually may not be very helpful because you are relying on this to write, but when you're actually interviewing, you may not have this option. So you can turn it on initially, learn it, and then turn it off. Okay, so what you want to do is I have to sort these two-dimensional array, right? This is a two-dimensional array, and I want to sort them based on their start value. So we can use this lambda capability of Java. Okay, and okay, so the compare between A and B is going to be based on the start values, right? So A0 minus B0. That means the start values. The end values would have been A1, right? And we know that A and B, both of them are like two-dimensional. So A has two values, each interval, right? Each interval is, say, one of the intervals is 1, 2. So in that case, it's A0 is 1 and A1 is 2. Okay. And similarly, say for the second one, 2, 3, right? If this is 2, 3, the second one, then B0 is going to be 2 and B1 is going to be 3. Okay. And so when you are comparing 1, 2 against 2, 3, it's the comparison between A0 and B0. So obviously this one will be like come before this one because we are sorting, we have directed the sort. Okay, so so we will start comparing from we have done the sorting, right? After the sorting, we'll start comparing the overlaps starting from the second interval, right? So we set the initial end to the last value or the closing or the like end value of the first interval, right? So this is interval 0, so that is the first interval. So let's start comparing the overlaps from the second interval. So int I equals to 1, since we want to do it from the second interval. And then we keep on going up to the last interval. And for each of the intervals, we keep on checking if this current interval starting value is less than the current end, in that case we can say this is a overlap, and if that is an overlap, then obviously one of the intervals need to be removed. That's why I am doing this result plus plus. So I'm adding one to be removed, and then I have to update my end value. So the end value is going to be the minimum of the current end and the end value of this. Okay, so okay, I made a mistake here. So I have to check for the overlap, I have to check the start value against the current end, and the new end is going to be the end of the current interval, right? With the previous end, and whichever is minimum, because I will be in the greedy approach, I will be removing the one that has the later or bigger end value, and then I'm done, right? Okay, so that's what happens if the current interval, which is ith interval, overlaps with the previous interval. If it doesn't overlap, even in that case, my end value changes, right? So from the example here, you saw that, say, when I was comparing between C and B, right? So I compared between the current end value was this, I compared this and I see that there is no overlap. So what I have to do is I have to change the end value to the end value of the current interval, right? Okay, so that's, if I do that, in that case, the end is going to be the end value of the current interval. Okay, and then I return the result. Okay, so this is the minimum number of intervals I need to remove. And what is the time complexity of, okay, so let's run it. And you see that, yeah, so this is accepted. Now, what is the time complexity of these algorithm? As you can see, if there are like n intervals, right? The sorting needs order of n log n, right? That is n log n. So this is the time complexity. And then we actually read through all the intervals. And every time we just compare against its previous interval for the overlap, and we just remove it. We keep it or we remove it, right? So it's just an order of n affair. Just iterating through all the sorted intervals, and so overall the time complexity is going to be order of n log n. Yeah. Now space complexity, actually we didn't use any extra space, so we don't have to worry about it. Okay, but it's the only space that's needed in the sorting algorithm. So you can say that space complexity in the program, we didn't do anything, but we did a sorting, right? So space for sorting, that is the space complexity. And it actually depends on the language, because different languages use different sorting techniques. Some use quick sort, some use other sorts. So it's whatever space is needed for sorting. Okay, so that's it. Thank you very much for watching. We'll come back with another problem.